Let's consider our training room application, and let's assume they use this room as a distance learning space. This means that they need to have microphones for the students in the room to be heard by the students at the far locations. Plus, you need to be able to have the instructor and the students hear questions coming back in from those far locations. This makes for some complicated audio, but it's no issue for a DSP or digital signal processor to handle. Before we move on, I want to note that we are using the term digital signal processor to denote a wide array of physical hardware, and down to the core of the matter, that's all it is, a specialized microprocessor. The same term is often used to describe software plugins for recording environments and built-in effects in mixing consoles. A DSP can pack all the signal processors we've discussed and more into a single device, and in many cases it will act as the heart of your installed sound system where all audio sources and audio outputs flow from. Much like we've seen throughout the videos, there are many different options to choose from. Specifically in the installed sound market, there are really two trains of thought. You have fixed architecture DSPs where the signal processing for the inputs and outputs are in a fixed order. The signal processing available to you to work with is determined by the manufacturer. Then on the opposite side of the coin, someone gives you nearly every signal processor you can think of with an infinitely sized rack and says, do what you want. That's open architecture. You could argue that there are hybrids of the two where the operator may be allowed, as an example, to choose whether they use a compressor or a gate in an otherwise fixed signal chain, but we'd still call this a fixed architecture DSP. There are multiple models within both families, but you'll quickly find BSS has a far more expansive and versatile line. Not to mention, a BSS solution can scale up quite nicely as the audio needs grow with a given solution. But that's not to say there isn't a need for Zone Pros in the market. The Zone Pro offers standard end-user functions like source select and volume control to advanced system control, including a built-in clock that can provide programmable system changes throughout the day or week. The following list, while not comprehensive, compares and contrasts the two families of products. Let's look again at our higher education environment. Our training room will be used as a distance learning training room. Distance learning is a way of learning remotely without being in regular face-to-face contact with a teacher in the classroom. So let's look at our single room, and we'll be conservative with the number of inputs and outputs required. We have 2 microphones for the instructor, wireless or gooseneck, and 4 additional microphones spread throughout the classroom for students to utilize. Next, we'll add 2 line-level inputs for a Blu-ray player and an instructor's laptop in the event that he or she needs audio from their computer. So that gives us a total of 8 inputs, and because we are just focused on a single room, we only need 1 output. What are some other requirements for this application? The instructor will need to be able to easily choose between wireless or gooseneck microphone, and will have a total of 4 open microphones used for student speech, so it would be wise to use an auto mixer, which could be a piece of hardware or digital representation. We'll also need the ability to choose between the Blu-ray player or the instructor's laptop audio and have the option to mix that with the mic feeds. On top of that, we'll want the option to apply signal processing where needed. So how can we account for bringing in all these audio sources, apply signal processing, account for source selection, and mix where needed? Also keep in mind we've spec'd in a CDI 2300 Blue for our amplifier, which supports BlueLink audio. What should we use? I'll give you a second. If you answered, I don't know because a second wasn't long enough and there are so many choices, I don't blame you. The most compact solution that meets all of our requirements would be to use a BSS Blue 100. The Blue 100 is one of BSS's fixed I/O options supporting 12 analog inputs and 8 analog outputs in addition to 48 channels of BlueLink audio, allowing us to send the audio to our amplifier over a single Cat5 cable. That's right, we don't have to waste time connecting a 3-conductor cable between the processor and amp if we don't want to. It also includes nearly every type of signal processor we may need for this application, including 2 different types of auto mixers for our microphones. Yes, we have some unused I/O, but it's better to have a little more than not enough. Here's an example of what the signal flow may look like inside the unit. Now let's consider distance learning as a requirement where a student may use a soft phone on their computer to call in. We'll need the ability to hear that student through local sound reinforcement in the classroom, and we also need the option to send our audio sources to that student. What should we use? The BSS Blue 103 is a great choice for this application as it offers 8 inputs, 8 outputs, 48 channels of BlueLink audio, and voice over IP.